So I know it's a little early, but if you guys have questions, I'm more than willing to start now if you want to go through those, or we can wait until the official 8:30 start time. It doesn't matter to me. I mean, we're all here, so if we have questions, I can go ahead and answer those. Or you guys may not, I was going to say, or you may not even be at your computers. You may have just signed on. All right, well, let's go ahead and take a look at that compute accuracy method. Oh, wrong thing, sorry. So let's make sure first we have a clear understanding of what the compute accuracy is. So when we're computing the accuracy, let's find that down here. Compute accuracy. So we're definitely going to display there's no on target drive. So there's got to be, so apparently the accuracy has to involve on target drives, right? If there are no on-target drives, we're returning 0. So that should be our very first check. Do I have target drives greater than or equal to 0? Okay. And then let's see, does it do anything else talk about here? Okay, so and an on-target drive is fairway or green. However, keep in mind that just because those are spelled with a capital F and a lowercase airway and a capital G and a lowercase reen, they may not be entered that way. And if I spell it all in lowercase, is it not an on-target drive? If I put all fairway in lowercase, would it not be an on-target drive? Okay, cool. So the next thing to consider is, so what are you dividing? So there's two variables that you're probably dividing. If we don't have any target drives, so that's probably your divisor, right? So you're dividing by the number of drives that were on target. So the total number of, or is it the vice versa? So probably your on target drives is your numerator divided by the number of holes that have been played, right? So that tells us what your accuracy is. Okay, is that what you're computing? Okay, cool. So how is your number of holes, how is that defined? What data type? Don't give her the answer, Matthew. Oh, no problem whatsoever. Actually, it's early. We still have like 2 minutes. No, so if you look at your instance variables, so you have an instance variable up at the top, right, that's defined as the number of holes that have been played, right? that tells you how many holes the player has played. Is that true? Let me open up my so if we go up to the top of the player class, you have these instance variables. So let's take a look. You've got the player class, I guess, contains hole number, the player's score on the holes, the length of the player's drive, and the location of the drive. So that's what you have in there. But you've got your scorecard class, right? And the scorecard class will tell you how many holes the player has actually played, right? Would that be true? The scorecard class tells you how many holes have actually been played. So let's take a look at the Java docs for the scorecard class. So get holes played returns to the number of holes that have been played. So yes, and what data type is that returned as? So that gives you a value in what data type? Integer. Okay, cool. And then we have an instance variable in here that tells us how many holes, do we have how many holes were on target? Where am I at? Well, we're going to have to get the number of holes that were on target. So we actually have to go through, because we're computing accuracy, so it's going to be the number of on-target drives divided by the number of holes that were played. Okay? So the scorecard class, let me bring that back up again, is not going to tell us. It tells us what hole was unplayed. Let's see. Hole number, length, location of the drive. And don't we have some other fields that we're storing? The record play method calls a method on the scorecard class. It adjusts it, full drive if it had sufficient length and the drive was on target. Compute accuracy had no on target drives. So are we looking for full drives? Only full drives are considered for being the longest drive. No full drive, so it gets us the longest drive. Compute the full average, so it's the average number of full drives. Compute the drives on target. So we need to determine public find extended number of holes, course. So for the scorecard class, we record the score, but then we need to determine if it was on target. And let's go back to that scorecard class to see what we got. Number of strokes, compute versus par, gets the whole of par played, the score on the whole, record the score, and toString. But then we determine if we're storing somewhere the number of on target. All right, let me pull this up. So you can just tell that golf confuses me just as much as it does you guys. The number of drives on target. So we already know that. So it's the number of drives on target divided by the number of holes that we played. And what data type is our drives on target? Integer. Okay, great. So if we have an integer, so let's say, so we only have 6 holes on our golf course. Let's say we played 5 holes, and of those 5 holes, 4 of them were on target. So it's integer. 4 divided by 5 equals, what is that value is that going to give us? 0. Yep. And how can I make that so that it does not give me 0? Yes. So, but we don't know, like everything is a variable, right? So we're setting our total holes or holes played or whatever you want to call this, holes played equals our scorecard object, so card.get holes played or whatever it's called, right? Okay, so we've got that, and we know that this is an integer value because it returns integer, okay? And then we know that we've got our integer drives on target, right? That's what that was called. Drives on target. So we know we've got that. So Dylan's got the right idea. If we're computing our average is going to equal this dot drives on target divided by holes played, that's going to always return us a value of 0. Okay, because that's integer division. And you don't want to use the modulus because the modulus is going to give you the remainder, which is not your percent. Because 4 divided by 5, if I pull up my handy dandy calculator here, 4 divided by 5 should be 80%. So 0.8, I'll multiply that by 100, that's going to give me 80%. But if I do the opposite of 4 divided by 5 and I give it the remainder, it's actually a value of 4. Okay, so 4 divided by 5 is 0, remainder 4. So I would get a 4, not 0.8, so I'm not going to get the value that I want. But I do need to convert one or the others of these to a double value so that it will give me double division as opposed to integer division. And so we've got like 3 or 4 different ways we can do that. So we can take this is our basic, this is not 100% correct calculation, okay, because I'm not sure that these variable names are right. But I can take this and I can multiply my numerator by 1.0, right? That converts the top to a double value, and that gives me a double result, okay? I could convert my denominator to a double value by multiplying that by 1.0, and that would work as well. So in each one of these cases, that will give me a double value. And then, of course, this whole thing, I'm going to want to multiply, so average equals average times by 100 to convert it from the 0.8 to 80 point, whatever, right, to make it the percentage, so 80% versus 0.8%. Okay, so I could do that, or I can do what's called casting, where I say I want to cast this as a double value. So I'm going to take this integer value, target, and I'm going to put a cast in front of it. So I can cast it as a double. You have to spell it correctly. But what this says is take this value and convert it to double. Or likewise down here, I can cast this one as a double, has a parentheses around it. Okay, so both of these two statements, actually all of these statements will accomplish our end goal, which is to get us a double result as opposed to an integer result. And so it's just a matter of what your preference is. So if you like this, go with that. If you like this, go with that. If you like the casting, go here or here. All these will result in the same thing, and then you need to multiply it by 100 to take it from a point to an 80 or 75 or whatever we have going on there. Now, I'm not sure that that is your problem. Okay, so if you're still getting the 0 method, then the question is, what is your upper value and what is your lower value, right? Because you're casting, so there's got to be an upper value and there's got to be a lower value. So the question is, what are you actually multiplying to know for sure that they actually contain a value? So, okay, so this .card.get holes played, does it have the open and closing parentheses at the end? Okay, because it's a method that you're calling, right? All right, so what I want you to do, which you don't want to keep this in here, and this is a, but it's a short-term solution, so you want to just stick it in there but not leave it in there, is put a system.out.print statement and print that value. And then run your code and see what gets printed out. And do the same thing for your denominator. So print out your numerator and print out your denominator so you can see what those values are. And then you'll run your test cases and it'll generate output. So Dylan's asking you, are you getting 0 in your unit test? So when you run your test cases, is it giving you a value of 0? And that's why you're saying expecting this but getting 0? Okay, yeah. So stick those print statements in there, printing your numerator value and then your denominator value, and then run your test cases and see what output you get to the console and see if they contain the values that you're expecting them to contain. So while Liz, did you already, I don't know if you already got that done or not. Not in the test, because that's not where your values contain. So if we're in here in the player class, so you're computing the accuracy, right? So you have your denominator, and then just put a print statement here, system.out.println. You don't want to leave it here, denominator, okay? You don't want to leave it here because it's not appropriate to put print statements in here, but for a short term, trying to figure, it's either that or use the debugger, and then do a system.out.println numerator. You know, like whatever you called your variables. So if you're just calling directly this.hold.get, you know, this.card.get hold played, then you could put that in there, this.hold.get cards played, and then put it in here. But then you'll run your test cases, which will kick everything off, and this should generate output to the console then. And you'll be able to check and see if it gives you the values that you're wanting. But you'll want to comment these out then before you submit your code. Does that make sense, Liz? Well, it'll pop up a console window. So just like when we run our main. Well, and you can do what Matthew said as well. So another option is let's say, so if I go to the solution here, I have to compile all these things, but let's compile them all. Compile. So we've given you compile. All right, am I all compiled here? Okay, so we've given you this tournament demo class right here. We don't really do anything with this because this is written for you. So this is another option for you. So what you can do is you can come up here, and so this gives you just output. So if I were to just run this guy, just right click and do a void main, you know how that little console pops up? Here's all my output. So this is the sort of thing that should pop up if you stick that right inside of your class. This should pop up as well. So you can see here it's telling me driving accuracy and all that stuff. Now if we open up this tournament demo here, you can see it added 6 courses, and I believe this should correspond to the 6 courses that were defined for us in the player test. So let's just check that out. They're not quite the same, 433, 512. So they don't match exactly what was defined in here, but you can make them match. Like this is your tournament demo, so change these to contain the same values that you have over here. Easier than retyping all those is just to copy them and paste them all. Okay, so you can make a match exactly the same. And then here we have different, record plays. So go to wherever your test case is and record them exactly the same way that you have in your test case. So I don't know that I don't know that I have any stuff in here. Compute accuracy. No, I don't have any values in here, but go to wherever your compute accuracy is and plug those values exactly into the record play. And then you may print out, you've got a method that tells you right here, get full drive average, where you can get your drives on target, so you can find out how many drives you actually had on target, right? Which is one of your values, so you could call that and you could plug that into your demo, or where did it go? You could plug that, I mean, here it's just printing out the toString information, but it doesn't have to. Well, let's see what would happen if I compile this and print it out. So this tells me how many holes were played, which would be your denominator or your numerator, your denominator, right? Total strokes versus par, longest drive. It gives me accuracy, but it did not tell me the number of full drive holes that I had. So I would need to also plug that information in there as well. So, which is, closed it down. I don't want to go in there. Go in here. Get drives on target. So I could come into my tournament demo, which is, I think, Matthew, is this what you were talking about? Okay, if it would open up. And I could actually print in here system.out.println drives on target equals player one dot get drives on target. Okay, so this tells me my drives on target were 5, my number of holes played were 6, so my driving accuracy was 83.33. If I pull back up that calculator, 5 divided by 6 is 83.33, so I'm correctly calculating. So that's another option for you to to have a visual, more of a visual as to what your output is. Did that help, or did that just make it more complicated? Or Liz, are you off coding now to see what you can figure out? All right, tell you what, you do that. We're going to be here for another 45 minutes, right? So you work on that, and then I'll answer other questions, or you can hang out, whatever you want to do, because we'll be here for 45 minutes. So you ought to be able to get that printed out and see some of your output, and then, you know, and definitely when you see something, you can come back and ask another question. What questions do you guys have? Does anybody else have questions on Lab 3? Okay, Matthew, what do you, I know you sent me some code, which I did take a look at that. And if anybody else has questions, don't hesitate to post your stuff out there as well. Oh, so let me go over to my student solution one. Okay, record score. So we've got 1 here, right? Is this the if state you're talking about? The hole is less than 1, or the hole is greater than the course.num of holes? Is that the one you can't figure out, or are we down here? Longest yards. Right. You don't have an else for that, right? You only have an if. So you have if it's on target, if it's a full drive hole, and then if it's greater than the number of longest yards, right? So the key is to trigger it to be true and to be false. Okay, so let's think about this for a minute. So let's say we're playing, holes. Well, we've got our different holes here. Okay, where is that? Okay, so we've got our holes here. So a full drive hole has to have greater than 400 yards, right? So hole 1, 2, 5, and 6 qualify as full drive holes. So those 4 holes qualify as full drive holes. So let's keep that in mind. 1, 2, 5, and 6. Okay, 1, 2, 5, and 6. Those are my potential full drive holes, right? But they also have to be on target, which means they have to be either in the fairway or the green in order to be a full drive hole. Okay, so we need to check, is it on target or not on target? So it doesn't matter if it's a full drive hole to be on target or not. So I can use hole 3 or 4 to test that on target or off target thing, right? So I could do a record play, and I can't remember what the parameters are for the record play. Where is it at? Record play. Okay, so to test that first if statement, I need to give one that's on target, one that's not on target, right? Okay, so let's use one of our non-full drive holes to determine the target or not target. Let's not waste one of our full drive holes. Let's do a 3 and give it a rough. And so that tests the wrong location of this, right? That tests the not true condition. So that tests the opposite one of this. And then to test it is on target, then let's use one of our full drive holes. So like hole 1. And let's give it green. Okay, so we've tested this first one. We've set one that's not on target and one that is on target. Cool. Okay, it could have, but I'm just kind of running through the whole shamil. Okay, so now we need to test if it's a full drive hole. So, well, we need to have one that's on target, one that is a full drive on hole, and one that isn't a full drive hole. So, number 1 qualifies to test this one here is a full drive hole because this is a full drive hole. It has 400 yards. But then let's test another one, which would be hole number 4. Let's make hole 4 also on the green. So that is not a full drive hole. Okay, so this one tests the not condition of this, the opposite of this one. This one, these two test, it is on target. So these two get me into target, right? So I've got one that's not on target, so that's the opposite of this one. These two are both on target, but one of them is a full drive hole, number 1. Number 4 is not a full drive hole, so that tests both sides of this if statement. And now I need to test for the longest yard, so I've got one coming in at 290 yards. So what if I do another one coming in at, so this could be hole number 2, 300 yards. So that would be greater, so that tests the greater than component, right? And I could even send in another one here, which would be hole 5 at maybe just 200 yards, which would be the opposite of the longest yard. It would not be greater than the longest yard, right? What do you think? Is it just highlighting in pink to say that these areas weren't tested? Yeah. So the big key is, notice here I'm only checking for one thing. I'm spelling it poorly, but I'm only checking for one thing. Is the drive on target? And that's it. So these two things test for on target or not on target, right? So this tests both sides of that on target. I don't have any other conditions, no ands or anything else. This just tests for one thing. Is it a full drive hole? And so I've got a test for that because these two guys together test, is it a full drive hole? Because 1 is a full drive hole, 4 is not a full drive hole. But I'm not combining anything. So I'm not saying, is it a full drive hole and is it on target? Okay, I'm only asking, is it a full drive hole? I already know it's on target because this is already true. So if I get here, it's on target, right? So, and that's a problem. If I said if it's a full drive hole and location is on target, then I can never test this portion of my statement because it will always be on target because I know it's on target already because I'm in here. So if I put this on here, you will get that statement that it's not tested because you can never make it not on target at this point or you would not be inside this if statement. Is everybody following that? What I'm saying there? That I can never test this because I can never make it not on target at this point in my if statement. You guys all see that? Okay. So you know it's on target, so you don't need to check for that. And then likewise down here, I don't need to say, and it's a full drive hole and it's on target because I already know those to be true statements. Otherwise, I would never be here to begin with. So I only want to check for are my yards greater than my longest yard. And so I did that down here by I have this one. Well, first I recorded a yardage of 290, okay? Then I made it to 300, which is greater, so I found a larger one. And then I went to 200, which is less, that took me in there. So I needed to find things that met both of these conditions and then manipulate that third condition to put some higher and some less than to make sure that I'm properly testing all those conditions. It would be easier if we had 18 holes, but because we only have 6 holes, you really have to pay attention to what the holes are. Other Lab 3 questions. All right, so if you guys think of other Lab 3 questions, don't hesitate to bring them up. I'm going to just spend a little bit of time on the assignment class, and then I was trying to, and then I would like to talk a little bit about Lab 4 because believe it or not, this is week 9, right? Which means there's 9, 10, 11, and 12 4 total weeks left in the class. So actually, and we're a little bit ways through this week 9. So really 3 weeks and 5 days left in the class. We have 2 labs left to go. So you're essentially spending 2 weeks on lab 4. It'll be 2 weeks from Wednesday, and then just a week and a half on lab 5. For the homework for today, well, I did not bring up the homework for today, so let me bring that up. Never pulls up. You know how it's supposed to like remember where you last used something? It never does that for me. Okay, homework 8 for C and D. Okay, so you're looking at errors in the, is this where you're at? Correct the errors or logic errors in the snippet of code. Okay, so you've got code right here. So the error, you need to find the error. Did you try copying it into BlueJ and executing it? Okay, so manually look at this. What's the highest number? What's the lowest number? I'm sorry, you probably can't even see that. Let me bring it up bigger. So manually looking at these, what's our highest number versus what's our lowest number? Okay, 1 and 49. So 1 is our lowest, 49 is our highest. So let's go to BlueJ. Let me open up something other than the lab. I am in the right place, right, that you wanted me to look at? Week 8. Did I compile clean? Yep. All right, so let's compile it. We're getting our numbers, so the only thing I don't have is any outputs. Let's do a system.out.println lowest and a system.out.println highest. Printed 1 and 3. That's not what we were expecting. We're expecting 1 and 49, right? So there's got to be a problem with this logic and how it's choosing the lowest and the highest. So let's walk through this one number at a time. Let me go back over here where I've made it bigger. Okay, so the first number is 7. So we set the lowest and the highest both to the first number in the list. So both our lowest and our highest equals 7 at this point before we enter the loop. Okay, so we're just saying, all right, very first number, it's both my lowest and my highest, and now let's move on from there. So we've got 7 in there. So then we work through it one at a time. So we look at 7. 7 is not less than the lowest, which is also 7, so we don't do anything. Then we get to 2. 2 is less than 7, so we change. Our lowest now contains 2, but our highest still contains 7, right? We move on to 6. Is 6 less than our lowest? No, because our lowest is 2. So we come down here and we say, we just set our highest equal to 6. Wait, why did we do that? We just set our highest equal to 6. Okay, then we get to 4. Is 4 less than 2? No, it's not. So we set highest equal to 4. Then we get to 12. Is 12 less than 2? No, so we set highest equal to 12. Are you seeing a problem here? Can we automatically assume that just because the number isn't the lowest, that it's automatically the highest? No. Because what we're doing is we're saying, well, if it's not the lowest, then it must be the highest. And what happens is we get all the way to 3, eventually our lowest becomes 1. We get all the way to 3, 3 is not less than 1, must be our highest. And we set our highest equal to 3, and 3 comes out instead of 49. Well, it doesn't even need to be an else. Like, do they need to be connected to each other? Like, is the highest, checking for the highest, directly related to checking for the lowest, or are they really two independent checks? So you could definitely do an else if you wanted to, or you could just make them two completely separate if statements. If it's less than my lowest, it's my new lowest. If it's greater than my highest, it's my new highest. They don't even need to be related to each other. And you've got a similar problem going on down here. Okay, so here we're looking for a target, a specific value. So we're looking for a number inside of an array. And so you could, you need to do a little bit of setup work with this particular one, but you're looking for a number inside of an array. So can you automatically assume that just because it's not in position I, that it's not found at all in the array? Like if we were so let's assume this is our number list up here, and I'm looking for the number 12. And so I come in and I check the very first number, which is 7, and I say, well, 7's not equal to 12, so therefore it doesn't exist in my list at all. Is that a valid assumption? No. So you just want to say, is 7 equal to 12, return true, and that's it. That's all you want to do. You don't even want to look for this else. You set it, I'm assuming that I'm not going to find the number. And then if I do find the number, I say, woohoo, I found the number, and I set it to true, but I don't need an else. I'm not going to do anything if it's not equal. I'm only looking for a true, if I find it, I'm going to set it equal to true. And then when I get down here, I just return whatever found is. If I found it, found is now equal to true. But if I don't find it, I had originally set it equal to false. Okay. Actually, you'll never get to the last one. You'll only ever check the first number every single time with this logic, because you're either returning true or you're returning false. So you will only check for 7, and you'll never even look at number 2 if this is our array up here. Okay. So that's why I know it's tempting to think, oh, I always need an else statement. You don't. Well, I guess, I'm sorry, you're right, Dylan. You will, I'm sorry. See, this is how I would write this. I wouldn't even do that. I would just say return true. And I wouldn't even do this here just because I'm lazy, and I would just say return false. But you're right. The way that was written, it would check all the numbers, and the only time it would work is if the last number matched. But I would do it this way. And so in which case I would never move beyond the one number. I would always get the first number. But yep, you were right. I'm sorry. So you don't always need an else. And that's where you have to look, and you have to go, does this really hold true? And run through a couple examples and say, is this really going to hold true here? If I do this, does this hold true every single time? And that'll let you know. Okay, so just let me ask you guys what you would prefer to do here, because we've always got next week, which is week 10. You do technically have 2 weeks from tomorrow to complete your lab 4. I was going to go over the homework 7, the assignment 1. Do you want me to go over that, or do you want me to focus on lab 4? I mean, will you even work on lab 4 this weekend, or what do you guys think? It would be the mini lab in assignment 7 or homework 7. Okay, well, let's just go over the homework, and I think it'll, well, homework, the mini lab from homework 7 is directly related to the mini lab in homework 8, right? Because you're just building upon the mini lab in homework 8. So there was just some couple key things I wanted to go over in that mini lab that I saw different people doing, and so I think it just warrants a discussion. Okay, so first off, you have to kind of go, well, what the heck are we doing with this, right? So let me get rid of all this stuff. So let's just say we've got an assignment, and let's just go with homework 7, just for an example. And it is worth a total of 25 points. So the maximum that you could earn on this assignment is 25 points. Now you can earn 0 points on it, you could earn 25 or somewhere in the middle, but this is the maximum that you're going to earn. And we want to kind of record all of the, what this class has earned on this assignment. So we've got Fred here, and he earns 18 points. And we've got Sue, and she earns 22 points. And we've got Sam, and he earns 24 points. And we have Bill, and he earns 10 points. Okay, so let's say that that is our class. So what we want to do is we want to take it in, and so we want to be able to come up with a total. So if we have these 4, we're going to have a total of 4 total assignments recorded, right? Or scores, let's go with that. 4 total scores recorded. Okay. Our gross total of all of these points, shoot, I closed down the calculator. Let me pull that back up. Is 18 plus 22 plus 24 plus 10, so that's 74 is the total points overall, right, for all the different scores. Our min is going to be 10 points. Our max is going to be 24 points. Our average is going to be the 74 divided by 4 equals, so 74 divided by 4 is 18.5. So 18.5 is the average earned on a given assignment. The average percent is going to be that 74 divided by 4 divided by 25, right? Because that will give us our percentage. So it's divided by 25 is 74%, which is weird that it's the same as the score, but it just is what it is. So that's our average percent. And then our average grade is going to be a C, is our average grade. So just looking at these numbers, this is what I can tell. So you kind of have to go through this. And I know I'm going through it fast, right? But I've done this assignment a lot, so I know what our expectation is here. I did just make up these numbers, but this is what we're kind of doing, right? So we've got a homework. It's got a certain number of points that are allocated to it. We're going to record some different scores. We're going to add those scores each time through, and we're going to be able to determine the min, the max, the average earned, the average percent, and then our average grade that comes out the other end of it. Okay, so you first need to know, you need kind of like an example, just kind of like this, and don't try to make it super complicated or anything, but I did intentionally pick something that was 25 points because I didn't want to pick 100, because then your average earned and your average earned and your average percent would be the same value, right? And so you may not be correctly calculating your average percent correctly if you're not, if the number is not equal to 100. So I kind of intentionally chose something different. All right. So then let's just take a look at what we've got here. So we've got these instance variables. This is what you've got. The name of your assignment, total points, maximum grade, minimum grade, sum of the grades, and then your count. Those are your instance variables. It tells you right here. We have a constructor that receives 2 explicit parameters, the name and the total points for the assignment. So that means that our constructor, sorry, I'm pulling in my Python, public, no return type on a constructor assignment, and we have 2 explicit parameters, the name, which is going to be data type string, and then, let me widen this out a little bit. the total maximum total points, which is integer, which would be total points. Okay. And then the whole purpose of our constructor, right, is to initialize our instance variables. So we have the name of our assignment and the total points, which we've got those two as explicit parameters here. So we'll set those equal to those values, and then everything else we're going to set to 0. There's nothing going on there. Okay, and that's all we have. So it says, you know, initialize those fields appropriately, set reasonable defaults. 0 is a reasonable default. Now, with this recruit score, we're only getting one score at a time. We're not taking all 4 of those scores in. It's going to be called one at a time, and we're recruiting one score at a time. So public, it doesn't return anything, right? It's explicit. It takes in one explicit parameter of the score to consider, and it updates based upon these, but it does not say anything about returning. So it's going to be void accrue score, and we're taking in one score, integer, and a score. Okay, now we've got to do these 3 things, or these, whatever this, 5 things, 6 things. If the score is outside of the range, so it needs to be in the range 0 up through and including the total points, we're not going to do anything. Okay, so if the score is less than 0, or the score is greater than our total points, okay, then we're just going to return, doing nothing at all, right? Just return. Nothing is happening. Yes, Dylan, 8, I'm sorry, I missed your question. Homework 8 is the same thing, but you're using arrays, and you're adding in standard deviation. So you're adding in like an extra calculation, and you're adding in a toString, I think, as well. So you're kind of embellishing your homework 8 or homework 7. Yep. Okay. So accrue score. Check and see, is it a valid score? If it's not a valid score, return, man. Just get out and don't worry about it. Yeah, absolutely. Start with what you had in week 7. Okay, so we've eliminated invalid scores. We are out if it's not a valid score. So then we need to, so we can take this one of 2 ways. We can add and then check our min, or check our min max and then add. Either way you look at it, we're definitely adding. So we can add 1 to the count of scores, right? Increment that by 1. And we can add the score to the total scores. So we're doing that no matter what. So we can do that at the beginning of this or at the end of this, but once we've determined it's a valid score, we're now valid, we've got to do this no matter what. And then we need to check, is this our new min or is this our new max? So the one thing we need to know, is this like my very first score? Is this the very first score I'm recording? Because if this is the first score I'm recording, it's both my min and my max. But if it's not the first score I'm recording, then I need to check it. So it all depends upon whether you do this at the beginning or you do this at the end. Okay, if I do this first, then I know if my count is equal to 1, then it's my first score. If I do this at the end, then I'm checking for a count equal to 0. Okay, so if I do this right here, my count is going to equal to 1. Okay, then I know that my min equals my score and my max equals my score. Because I don't have any scores recorded yet. This is my very first score, so this has got to be the true case. Otherwise, if it's not, if my count is not equal to 1, then I know that I've already got some scores in there. So then I have to say if my min is less than my score, if my score is less than my min, then my min now equals the score. And again, these are not else's. If my score is greater than my max, then my max equals my score. So no else here, because just because you're not my min doesn't mean you're automatically my max, right? So I'll just check them separate. All right, so this is accrue score. If it's higher than the previous grades, if it's lower than the previous grades, add the score, update the counts, and there you go. So check it. Is it valid? If not, get out. If it is valid, add to your count, add to your total, then check, is my count equal to 1, meaning it's my very first one. If it is, set my min and my max. If it's not, check to see if this is my new min or this is my new max. Okay. Get name, get min, get max, get count. Those are all good. For the average score, so the get, what is that? Public double get average score. Okay, so what I need to do is, it's going to be really easy. I'm just dividing my total of all my scores by my count, but I need to check, is my count greater than 0? Then I'm going to return the total scores divided by my count. Otherwise, I'm just going to return 0. And I have to check that because I don't know. My user could have created an assignment object and then immediately call this get average score without recording any scores at all. And so in that case, my count would be 0 and I would get a runtime error, divide by 0 error, and I'm done. Okay, so you have to check whenever you're dividing to make sure that your divisor is not equal to 0, because there's always the potential that you could end up with a divisor of 0 and a runtime error. Okay. Public double get average percent. So this is the same as what we're doing up here with the get average score, but we're dividing it by the total possible points, right? So again, we have to check to see if our total possible points is greater than 0. Then I don't really need to do the calculation all over again because I just did it. So I can say this dot get average score divided by my total possible points. And I'm returning that return. Else return 0. Okay, so let me line that up. All right, so get average percent is my average score divided by the total possible points. So again, check, is my total possible points greater than 0? They might have entered 0 in for the total possible points. Who knows? Users are entering data. We have no control over what they're doing. So just check, is it greater than 0? And if so, then take your average score that you've already computed up here and divide it by your total possible points. Otherwise, just return 0. And then the last is public string get letter grade or something like that. And this is based upon your average percent. So if this dot get average percent is less than 60, then you'll return an F. You know, if it's less than 70, return D, and so on. Okay, now what I encountered, just a couple things to let you guys know is, oh, I know I had some people who, rather than, who wrote, you know how we have like set and gets for everything? So we have our sum of grades and a count of grades. So I had some people who wrote a public void set count method. And then they had a public void set total for not total points, but total scores method in, you know, in total. Okay. This is never, ever, ever a good idea. Any guesses as to why this would never be a good idea? I mean, so far we've been doing set and get methods for all of our instance variables. So why would we not want a set method to set our count and to set our total of all of our scores? Well, yeah, somebody could, if you have those set methods there, then somebody could change those values to anything they want. Exactly. And it could screw up everything. So let's say we've had these 4 values entered and we know that's 4 scores for a total of 74 points overall, but then somebody calls the set count and changes our 4 to a 7. Now we're dividing 74 by 7, and even though we know it should be an 18.5 and a 78% and a C, now it becomes whatever that would be, 74 divided by 7 becomes 10.57 is our average divided by 25.42. So even though we know that there's only been 4 scores and it should come out to a 74% average, it comes out and says it's a 42% average because we let the user change values that we can compute ourselves. And the same thing for the total score. Maybe they didn't mess with the 4, but they changed our total score to be 300. And how is that even possible? 300 is not even possible. It's only 25 points, 4 scores entered. The maximum that should be is 100, and now it's 300 for the total, which gives us this astronomical percentage. So let's see, 300 divided by 4 divided by 25, it gives us 300%, which is really weird. But anyway, 300%, which is like, how can you earn 300% on an assignment, right? So if you can calculate something, you calculate it and you don't let the users enter the value, because you cannot be guaranteed that the users will correctly calculate or do values. So anything that you, the programmer, you want to keep control, and you want to keep your data pure. So anything you can control, and do not let users change your values. So you do all your calculations and do not let the user change their value. Okay. The other thing I encountered was they went this way, is if the score is less than 100, then it's an A. I think this is what it was. And if it's less than 90, then it's a B, and so on. Less than 80, it's a C. Less than 70, it's a D. Less than 60, it's an E. Why isn't this going to work? Yeah, I mean, theoretically, everything should be less than 100, right? So 60 is less than 100, 10 is less than 100, 70% is less than 100. So everybody would end up with an A. No matter what, everybody ends up with an A. So you always want to start. Now, if we went the opposite way and we said greater than 90 and greater than 80, then this would work fine, because once we've eliminated this, we've returned our A, all of our 90s are out of the way. And then we get down to 80s, all the greater than 80s get out of the way, and then we could go to 70s and 60s and so on. That would work. But the opposite way, everybody would get an A, which someone like that as well, but it's not properly eliminating. So you need to just double check your if statements to make sure that those come out correctly. Okay. So I know that was pretty fast, but we were limited on time as well. What do you guys think? Did this raise questions? Did it help to clarify anything? What other thoughts do you guys have? Oh, Liz, how did your testing go? You're not getting this, or with the testing? Okay. All right. Well, tell you what. Do you have a couple minutes, Liz, to hang around? You're not multiplying by 100. Are you getting a syntax error on that statement? All right, thank you, Matthew. All right, so I think it's returning 5.0. So I'm gonna work with Liz here for a minute. If anybody else, you know, has a question or whatever, if you guys are all good, then certainly feel free to exit out. Because I pretty much have covered everything that I really wanted to cover today. We'll definitely focus on Lab 4 next week, and I'll let you know Lab 4 you're not going to find as challenging as Lab 3. Okay, it just we're going to work on arrays with Lab 4, so that will be a thing that we're integrating into Lab 4, but typically Lab 3 is the one that people find the most challenging, all right? So, yep, no problem. Everybody have a great night, and Liz, stick around and we'll see what we can get going here. So Liz, can you paste in here your everything you've got for the test case for that compute average, whatever that is called, and then so I'll look at the test because sometimes it's the test data that screws things up. So let's take a look at that first. And do you want me to keep recording this or would you prefer me to stop the recording? Either way is fine by me. If it's easier for you to email it to me, you can do that as well since you're on 2 different computers. Oh, cool. Yeah, just for your compute accuracy, if you copy the whole test for that, just that method. All right, so I'm going to copy this. It never pastes quite that well, but if you give me a second, I'll be able to get this reformatted. So in the meantime, go ahead and copy in your code. I feel like I'm missing something. Tests, compute accuracy. All right, so you've got your holes played by calling that, so that's great. You've called your, or retrieved your instance variable, so you check to see if the holes played equals 0. You return 0 if it is 0. Okay, else you say on target divided by holes played multiplied by 1.0 multiplied by 100. So that looks good for me. So record. So we get our player. So you check no holes have been played, 0. So that should be working correctly, right? Okay. So record play. So 1 hole, 500 fairway. So that is an on target drive. So we have 1 hole. This one's on target. This one is also on target. On target. Actually, all 5 of your holes are on target. So you should compute accuracy. Drives on target, for this is the number of holes played. So technically this should come out with 100, right? Because all of your holes are on target. Now, oh, there was one more that I'm missing. One, three, four, five, six. I don't see hole 2. Do you have are you recording a score for hole 2 as well? So this was no holes played. And then you have hole 2, which tests to make sure. And so you're doing also the 0 again because they have no on target drives. Okay, there we go. So this is kind of how your test case looks. Okay, so first no holes played, and then we're testing for 1 hole played here. So it should also come, it's in the rough, so it shouldn't do anything, and we've got that. Okay. So let me copy this. And I'm just going to go out to, okay, I don't really want to, let me go back out here. Let me get rid of homework 7. Don't save. Okay. I want to copy my solution because I'm going to paste over the top of it. Okay, so I'm going to go into my player test, and I'm just going to copy your test code in there just to make sure. Okay, compute average drive, compute accuracy. Apparently I didn't copy. Let me try that again. Okay, so let's compile that. So it compiled. Now let's run the test cases and make sure. Okay, compute accuracy was 500, which is what you're getting, right? So it says it expects 0.8333, but was 500. Okay. All right, so we're getting 500, and the question would be why, so it's saying, and why is it 500 would be kind of a weird thing. All right, so we know, what was those, full drive holes. Let's go back into that player test. Three and four are not full drive holes, so 4 of these would be full drive holes. Still 500%. It should be not 500%. Okay. Should be 0, should be this. Okay, so we got that. Well, let's just add these holes. Well, let's plug those. Let's do it into the tournament dynamo, just like Matthew had suggested. Let's see if that gives us any easier output, and then I'll work on the other stuff. Okay. I'm not opening this stuff up right. Okay. Close this out. Tournament demo player test. That's what I want. I'm going to add in the same holes to make sure that they match. Okay, they all match. All right, I'm going to record the same scores that we have here. So I'm going to record two, and then the rest of these guys. So that should give me all the same scores. I've got my drives on target, and then I've got the rest of this. So let's compile this, and then let's just run it. Okay. So it tells me I have 5 drives on target. Oh, only 1 hole was played. Oh, you know what? I know exactly what the problem is. Stick that guy right there. Okay, so let's compile this now. So now it's running, but I'm getting 0.833 because I'm looking for, but was 83.33 because I'm looking for 0.833, and it should be 83.33 since we're multiplying by 100. So what you're not seeing, so what the issue is it's expecting the holes to be recorded in order. That you first record score hole 1, and then hole 2, and then hole 3, and then hole 4. And because you're recording hole 2 and then recording 1, it's stopping at hole 2, and it's not recording any of your other holes. So that's actually something that you'll find in Lab 4, that's a requirement. So they've already implemented that in the score class right now. So if you take out, if you go 1 and then 2 and so on, so you'll have to kind of get rid of this test case right here, but then copy this guy and paste him after number 1 right there, then you'll get the output that you're expecting. Did it work for you then? Yes. Awesome. Cool. Do you have any other questions? All right. Well, that should at least get you that much further. Hopefully, maybe even done at this point. All right. Well, you have a great evening, Liz.